Okay, we've looked at quadratic relations so far in standard form. What does A tell you when it's written in standard form? Yeah, it tells you the direction of opening. It tells you if it's stretched or compressed, right? C is the Y-intercept, okay? So we know a few things about a parabola from the equation when it's written in standard form. Today you are going to learn about a quadratic equation written in another form, which is called factored form. So it looks like this, okay? We'll talk about what these variables mean. Okay? Do you think A is any different when it's in factored form? Yes or no? So this value will still tell us the direction of opening and the shape, right? If it stretches or compresses. We're going to talk about what R and S mean, okay? So remember that it's X take away R and it's X take away S. And I'll talk about what these variables stand for in a minute. We know that this equation is written in factored form, which is y equals a x minus r times x minus s. So what is our a value in this equation? So what does this tell me about the parabola? If a is positive 2, what can you tell me about this parabola without graphing it? It opens up. Good. So it's going to look like this. And is it going to be stretched or compressed? Because a is a number that's greater than 1, we did this yesterday, it's going to be stretched, which means it's going to be skinnier than the parent function, okay? But we do know, if you recall from grade 9, how do you know when a point hits the y-axis? How do you know when there's a y-intercept? Yep. When x is equal to 0, right? If the x value is 0, we know that the y value will hit the y-axis. So can you make the x values 0 and figure out what y is? Okay, so let's do that first. So y equals 2, 0 plus 1 times 0, take away 5. All we're doing is making x 0 to figure out the y-intercept. So what's 0 plus 1? What's 0 take away 5? Negative 5. 2 times 1 is positive 2. Positive 2 times negative 5 is negative 10. So the y-intercept is actually negative 10. I want you to look at these numbers for a second. In our equation we had 2, a 1, and a negative 5. 2 times 1 times negative 5. So what did you notice about when you were finding the x-intercept? We had 2, a positive 1, and a negative 5. How would I write this as an equation to find the y-intercept using factored form variables? What do we do?
R is B.
Yeah, so we...
And 5 is S.
Good. So,
C.
yeah. So we multiplied A times R times S to get the y-intercept. If you look at the actual graph, here's the equation, I punched it in, and when we graph it, you can't really see here, but the y-intercept is at negative 10, just to verify, okay? And does this parabola open up like we said it should? And does it look stretched? Yes, okay? Now we're going to look at what R and S represent. Again, looking at the graph, I just kind of zoomed in so you can see the values. Where does this parabola hit the x-axis? This is my x and my y. Where does the parabola hit the x-axis? Okay, so you can see here, it intercepts the x-axis at positive 5 and at negative 1. Let's look at our R and our S values. Well, if I'm taking away R, would it make sense that x take away R, which is negative 1, becomes x plus 1? Was that my first part of this equation here? And then I'm taking away, we have x minus s, right? What's s? 5. That's the second part of this equation. So what do you think R and S represent? The zeros of the relation or the x-intercepts? Okay? So we can say that the x-intercepts are R and S. But you have to make sure you watch the signs when you plug it in because it's x take away R. Well, my first x-intercept was -1. When I take away a negative, it becomes positive. My second x-intercept was +5, so it's x take away 5. You plug it in. Okay, so I'm giving you another example. Based on what you just learned, first of all, is this written in factored form?
Yes.
Yes, so we know A, R, and S. Who can tell me how would I calculate the y-intercept of this relation without graphing it? If I ask you to tell me the y-intercept, yep. So which value? 2 times -4, good. Good. Equals? Good, -16. We're going to check this by graphing after, okay? So the y-intercept should be at -16. What are the two x-intercepts? And so R is +4. It's x take away R. This is R. R equals 4. So one intercept's at +4. And it's x minus s. So I have to make this a -2 in order for it to become positive, right? So the other x-intercept is at -2. It's always the opposite sign. Okay? This was supposed to say S, not R. Our x-intercepts are R and S. If you know the x-intercepts, can you find the axis of symmetry?
Yes.
The axis of symmetry is always in the middle of the x-intercepts, right?
Yes.
Because a parabola is symmetrical. So halfway between those two x-intercepts, now we know the two x-intercepts. How would I find the axis of symmetry? Yep. We need to find the midpoint of the x-intercept. So 4 plus -2 divided by 2. The axis of symmetry is halfway between the two x-intercepts. So 4 plus -2 is 2 divided by 2. The axis of symmetry is 1. So it's going to, the center, the middle of the parabola is going to be located at x equals 1. So now if I ask you to find the vertex, can you? We know that the axis of symmetry is x equals 1. So we can find the vertex because we know the axis of symmetry runs through the vertex, which means the vertex will be located at 1 and something. Well, you have an x value, plug it into your original equation, and find the y value. When x is 1, so I'm making x 1, what's y? Okay, just solve this. 1 take away 4, -3. Sorry, I forgot to put 1 plus 2, so that should be 3. So what's the answer? -18. Good. Okay, so when x is 1, y is -18, which means the vertex is located at 1 and -18. What's the maximum or minimum value of this parabola? If we're going to check this by graphing. The minimum value is what? -18. That's the lowest point it's going to go. So this is all the information that we gathered from the equation. All you're going to do is plot those points. We're just going to draw a sketch of this, okay? So we know it intercepts here at -16. It intercepts at -2 and +4, and the vertex is located at 1 and -18. Oh, my bad. We know 4 points on the parabola. I'm just drawing a sketch. I'm drawing a symmetrical curve. So it's going to look something like this. Okay, this is the vertex. This is the point where it changes direction. And the axis of symmetry runs through the vertex. Okay, that looks somewhat symmetrical for a sketch, right?
Made with Doodlecast Pro.